Hi, welcome to Celltomic, and today we're going to have another chemistry video, and in this video we're going to learn how to balance chemical equations. So before we start learning how to balance chemical equations, we need to first understand how a chemical equation looks like. So any compounds or any atoms you see on the left hand side, these are your reactants. So reactants are actually compounds or elements that are undergoing the reaction. Those elements and compounds you see on the right, those are our products. So these are the compounds or elements that we are going to get at the end of a reaction. The numbers you see in front of each of this element or compound, these are actually our coefficients. The coefficient is actually there to show us what the ratio of these compounds are. In this case, CH4 does not have anything in front. We can just assume that it's a 1. Anything that does not have a number in front, we can just assume it to be 1. So what this chemical equation tells us is that 1 mole of CH4 plus 2 moles of O2 give us 1 mole of CO2 plus 2 moles of H2O. So this means that CH4 and O2 has a ratio of 1:2, because this is what we can see from the coefficient. So the coefficient tells us the ratio. Since now we understand how the chemical equations are like, we can move on. So balancing chemical equations. So balancing chemical equations means that the number of atoms in the reactants has to equal the number of reactants in the product. So in this case, in the reactant side, we have 2 hydrogen atoms and 2 oxygen atoms. On the right hand side, in the product, we have 2 hydrogen atoms and 1 oxygen atom. In order for us to balance this equation, we need to ensure that the hydrogen on the left and hydrogen on the right is equal. The number of oxygens on the left and the number of oxygens on the right is also equal. For now, the number of hydrogens on the left and on the right are equal, but the number of oxygens on the left and right are not equal. So now we're going to balance the equation. In order for us to balance, we need to multiply either the left side or the right side by a certain value. So in this case, how do we multiply is that we add a number in front of the element and compound such that the number will help us to balance the left hand side and the right hand side. One thing we can do is that we can try to get rid of any odd numbers. So on the right hand side, we have a single oxygen. So we're going to add 2 in front of H2O, and now this gives us 4 hydrogen and 2 oxygen. So in order for us to balance this, we need to double our hydrogen, but for oxygen, we have enough. So now on the left hand side, we also have 4 hydrogen and 2 oxygen. And since this and this are the same, and this is the same, we now have a balanced equation. So now let's move on to some practice questions. You can pause the video here to give it a try. So for this practice question, we have iron plus oxygen gas, and this gives us iron oxide, F2O3. Okay, first let's see what we have on the left hand side and compare it to what we have on the right hand side so we can tell what we need to multiply by. In the reactant side, we have 1 iron and 2 oxygens. On the product side, we have 2 iron and 3 oxygen. Okay, so first we can see that we have this one and this one, they are odd numbers. So we need to double them. We're going to double the product side first. So we're going to add a 2 in front of the iron oxide. And by adding this 2, we're going to have 4 irons and 6 oxygens. This means we need 4 iron here. So this will then match the 4 iron here. In order for us to have 6 oxygen, we need to add a 3. Okay, you'll be asking, why do we add 3? Because O2 consists of 2 oxygens. So that means if we want to have 6 oxygen on the right hand side, we need to divide it by 2. Since oxygen exists as a diatomic molecule, we need to divide this by 2, and this gives us 3 O2s. So 3 diatomic atoms, 3 diatomic oxygen molecule will give us 6 individual oxygen atoms. This is why we place a 3 in front of O2 and not 6. So because if we add 6 O2s, this will give us 12 oxygens, and this is not what we want. Hence we add 3 instead of 6. So now to move on to another practice question. In this question, we have phosphorus adding oxygen to give us phosphorus oxide. So you can pause the video to give it a try. So first things first, we're going to count the number. So we have 4 P's because it's P4, and we have 2 O's because it's O2. In the reactant side, we have 4P and 10 O's. So the number of phosphorus is equal, so that's good. However, the number of oxygen is not equal. Okay, for this question, all the values here we have are all even numbers. So there are no odd numbers for this particular example. But this is actually quite a straightforward question, because we know that in order for us to get from 2 to 10, we just need to multiply by 5. So that's why the answer for this question is to add a 5 in front of O2, and that's a balanced equation. So that's all we have for today. I hope that you have learned something from this balancing chemical equation. So in our next video, we're going to learn how to write an ionic equation, and we're going to learn how to balance an ionic equation as well. So stay tuned to that video. If you do not want to miss that video, I highly recommend you to subscribe to this channel so that you'll be informed when that video is up. Continue to support us, and remember to always stay curious.